The last example we're going to look at is drawing a quick sketch of the following graph after describing all shifts and translations. This I'm not looking for an exact picture, but we want to have a general idea of what this graph is going to look like. So y equals sine of pi minus 3x minus 2. Right now we're not in that standard form that we talked about, so let's do some manipulation. First, on the inside, I know that my x is the first term inside the quantity. So let's rewrite that as minus 3x plus pi. But then the other issue I've got is I've got this negative 3 attached to the x. In order for me to clearly see my horizontal shift, I need to factor out that negative 3 so that the x is all by itself. So really what I'm dealing with is 2 sine of negative 3 x minus pi minus 2. I actually have to be careful with that because if I factor out that negative 3, I've got to factor out a negative 3 from that. So it's actually pi over 3. So let's be careful as we factor out both of those pieces. Now that I've got that factored down, I can begin to describe all the different things I see. This 2 in front is the amplitude. So we're going to have a vertical stretch of 2. We've got this pi over 3, which is a horizontal shift to the right of pi over 3. We've got a minus 2, which is 2 down. So vertical shift of 2 down. We have a negative sign in front of the x, which is a y-axis reflection. And what else do we have here? We are going to have a horizontal shrink that we need to deal with. And that comes from the negative 3 that we factored out. We've got to look at that period. So the period piece, we have 2 pi over b, and we had that b as being a negative 3. So we've got a period of negative 2 pi over 3. And that's going to be our horizontal shrink. We don't need the negative with that horizontal shrink because it's going to be the absolute value. Once again, that negative just indicates that we've got the y-axis reflection. So if we look at our original sine graph, we know the original sine graph looks something like this. So I'm going to need to apply all these different translations to it. The vertical stretch means I'm going to take this graph and make it larger. The horizontal shift of pi over 3 units to the right means I'm going to move it over slightly. The vertical shift of 2 units down means I'm going to go down 2. And then a y-axis reflection means I'm going to reflect it across the y-axis. So my new graph, it's going to be compressed because of my horizontal shrink. It's reflected across the y-axis. It's going to be stretched, move down, and move to the right. So that's just a very quick sketch. As I said, we don't want an exact sketch here because we don't have each of the points measured out. Just a general sketch showing that this is skinnier, it's stretched out more, there's a y-axis reflection, and it was shrunk. You can confirm this on your calculator to get a more accurate picture.